sum of consecutive integers from negative 22 to x inclusive is 72. So negative 22, negative 21, to x minus 1, x. If you add them all up, they equal 72. What's the sum of all numbers from negative 22 to 22? Zero, right? So you know that if you have a positive summation, that your x has to be greater than 22. But how much greater?
72.
So yeah, the sum of them will be, like that's your bound, right? It'll have to be the sum of these ones, the next ones, after like 23, comma 24, 25. The sum of all other numbers greater than 22 has to be 72. And what is that? Do you just guess and check, or is there a way you solve it? In this one, you just guess and check.
I think I'd be faster.
So what is it? What should it be?
25.
25?
Yeah, I just like each one I just subtracted like 72 minus 23, and then I subtracted 24 and then 25.
So that's a smart way, yeah. If you have the sum, if you have the total sum, you can just subtract what you know it should be. It should be greater than 22, so it should be 23. Subtract that one first, because you know that has to be it. There has to be 23 in there. Then subtract the 24, then subtract the 25 until you get to 0. And you can do that to an extent. If it told you, like again, the SAT won't give you one, but let me just tell you, if the sum of them all is, let me just say from negative, let me make it a little easier. Negative 6 to x, and the sum is 34. Let me make it a little harder. I'll just make it 34 right now. And it'll demonstrate the same thing. What should that answer be? 10. Yeah, 10. Yeah. The way to do it, I mean, it's clear that, like if I were to ask you what's the sum of 7, 8, 9, 10, you can just add those in your head for sure and get 34. But if you kept going to like, let's just say to 100, 7, to 100, what's the sum of all of those numbers?
Use the formula again?
Use a formula.
Use it twice and subtract.
Yeah. So use it for the 100, what is the sum of 1 to 100? 50-50?
Yeah.
And what's 50-50? What's the sum of 1 to 7 or 1 to 6? 1 to 6.
6.
6. And what's the sum of all those?
6 times 20 divided by 2. 21.
21.
Yeah.
So 50-50 minus 21, which is
5,000. Yeah.
And maybe you'll get that maybe on the GMAT too or something. If you take that, they say the sum of from negative 6 to x, 5,029. It would take you a long time if you were to take 5,029, subtract 7, 8, 9.
That would take forever.
So that's 18. And 20? Do you guys remember what H's and K's do to shifting?
Either shift. Okay. Yeah, they shift. I mean, they either go, H's that make you go left and right, K's make you go up and down.
Okay.
There's the X and Y.
So how do they shift from left graph to the right graph? Function F and function G.
Right 3 down.
Yeah.
Right 2,
Right 3.
right 3, down 2. Right 3, down 2.
No, up 2. I was just kidding, down 2. I was going the wrong way. Sorry. I was going from this one to that one, so I was going that one. Yeah.
Oh wait, explicit. Sorry, there's. So it gives you just two functions. Let me just write them out. 5 f of x equals, it's the x cubed minus 4x.
Yeah.
And they say g of x is what?
F of x plus h. F plus parentheses x plus h parentheses plus k.
That's k. Cool. So all I'm saying is that, how do we get rid of this, like, f of x definition in the g of x definition? Let's just make g of x like x's, nice x's, no other functions embedded in it. We want to get rid of this and substitute it for something else, which is just x's in case.
You substitute x plus h into f of x? Like
Yeah. So what is f of x plus h?
X plus h. Cubed, sorry. It's very easy.
X plus h
Cubed
cubed.
minus 4 times x plus h.
Okay, this is like one of the things that trips up the majority of people. Like, most people don't understand this, that like, if you have something that says f of x, I think the reason people don't understand this, let's say it's x plus 2, let's just say that, is because it looks like you're multiplying them, right? Because you use parentheses. So a lot of people read this as f times x or something. F of x, since we say f of x, like when you do 2 of 3, that means 6, because of generally means times, multiplied. So a lot of people think this is f times x. It's not. It's, and I know you guys know this, but I'm just for like when you guys tutor other people, like you need to make this clear, because their 7th or 8th grade teachers did not make this clear to them enough. That it's just a function. This is just a function. It's like a black box. That when you put an input in there, the x in the black box, this is the input, this is the x, you get the function output, which is f of x, or the y. Right, this is the function. So you can put anything in there. If I put like a triangle in there, then you get f of triangle comes out. Right? Because f of triangle, it's not f times triangle, it's f of, it's just basically plug in the triangle for the input. Triangle plus 2. That's what it would be.
It's just a notational convention, and it's extremely unfortunate that they use the parentheses that they already used for something else, because
Yeah, because it confuses so many people. Again, this is the input. X plus h is the input, which means that everywhere you see an x, you can put an x plus h instead. Just like if this was a triangle, you put a triangle there and a triangle there. So we know what this should be. This should be equals x plus h cubed minus 4 x plus h plus k. And that's g of x. I know I'm overcomplicating this because there's no reason there should be cubes in there.
No,
Do you find it the easier way? Is there just
you just know
a way
how
to shift
you just
it?
know how things shift.
So you
Like,
can
know,
just
if it
Yeah.
shifts right 3, then h is gonna be negative 3.
Yeah.
And if you know it goes down 2, then k.
so it should be
negative.
x
So like
plus 3 or x
like the
minus
function,
3?
like the actual function for g of x is, the g of x would be x minus 3.
Yeah, and then what's the k? It's
It would be plus 2. No, minus
minus 2.
So then you just do minus 3 times minus 2, and you get 6.
Okay, well this is an important point to note. I understand like you can solve it
Yeah.
this way, but it's it requires a lot of algebra and more space. So the initial line of reasoning I was going down can be used, where you can just compare two functions by you can transform functions. That's what it's called, transforming functions, either by translating them, just shifting them left or right, or doing something else. But in this case, they were just translating the function to the right and down. And that's something elementary from like algebra 1 or 2, maybe 2. But yeah, so basically it's the f of x, g of x equals f of x plus h plus k. F of x was again, there's x cubed minus 4x. And they gave us the graph for a reason. Like a lot of times they'll give you stuff for a reason. The reason was that g of x looks exactly like f of x, but shifted to the right by 3 and down 2. Meaning that this is h would be 3, but it would actually be f of x minus 3. And then by going down 2, you subtract k. So if you don't understand, if you don't get that right now, just go to the Khan Academy video for that, for shifting functions. And so you know what h and k are based on that. It's -3 and -2. And you multiply that, you get 6. E.